Good morning, all of you. Good morning, everyone. Are you hearing my voice? Are you hearing my voice? Okay, what about video streaming? What about board? Is it visible to you or not? You have to see through Zoom or YouTube. In any one streaming only you see the class. Then you can have clarity. Don't see simultaneously. If you see the video streaming simultaneously in both Zoom streaming and YouTube streaming, then you will get some time lag between them. That's why you see in any one of the streaming. Okay. And one advantage in YouTube streaming is DSR, some option is there. Suppose while class is going on, if you are unable to understand the point without knowing you, suppose I am going ahead in the class, at that time just you have to move, we can move back the cursor and you can see that completed point, and if after you understand that point, then you can go ahead along with the class. So that is an option. మన ఈవెన్ న్యూస్ లైవ్ వస్తున్నప్పుడు మనకి ఏదైనా దాని ముందు పాయింట్ ఏం చెప్పారనేది వినాలంటే మనం జస్ట్ కర్సన్ కొంచెం బ్యాక్ మూవ్ చేస్తే మళ్ళీ వినేసి లైవ్ స్ట్రీమ్ లోకి వచ్చేయచ్చు కదా. ఆ టైప్ లో ఫెసిలిటీ, అది ఒక అడ్వాంటేజ్. తర్వాత మన బ్యాండ్ విడ్త్ తక్కువగా ఉన్నా కూడా, ఇంటర్నెట్ బ్యాండ్ విడ్త్ తక్కువ ఉన్నా కూడా సమ్వాట్ క్లారిటీ, దాంతో వీడియో చూడాలంటే మనకి యూట్యూబ్ ఉపయోగపడుతుంది. మెయిన్ ఈ రీజన్స్ అవి. ఓకే. తర్వాత ఇంకోటి, ఇఫ్ యు ఆర్ హ్యావింగ్ ఎనీ డౌట్ ఇన్ కంప్లీటెడ్ పాయింట్ వైల్ లెక్చర్ ఈస్ గోయింగ్ ఆన్, దాన్ని జస్ట్ కర్సర్ని బ్యాక్ మూవ్ చేసి ఆ పాయింట్ వినేసి మళ్ళీ నెక్స్ట్ వెంటనే జాయిన్ అయిపోవచ్చు మళ్ళీ క్లాస్లోకి. అట్లా ఆ ఫీచర్ దీంట్లో ఉంటుంది కదా. సరే, ఇన్ ఎనీ వన్ యూ కెన్ సీ త్రూ జూమ్ యాప్ ఆర్ యూ కెన్ సీ త్రూ యూట్యూబ్, నో ప్రాబ్లం, ఎనీ వన్. బట్ ఇన్ యూట్యూబ్ దెర్ ఇస్ నో ఛాన్స్ టు చాట్, బట్ ఇన్ జూమ్ there is a possibility to chat. Okay, today I want to discuss the problems. Total I want to discuss the problems. All of you chat. Jack, you stop your video sharing. Karthik, okay. So here we see ballast pendulum was completed already. Raven, ballistic pendulum was completed already in elastic collision. In last week only ballistic pendulum I taught. Yesterday's continuation here. We are doing problems today. Today we are doing problems. Okay. So lecture sheet, in lecture sheet exercise 2 level 1 page number 45, you see which problem you need. Okay, I will say the first problem. A smooth sphere is moving on horizontal surface with a velocity 2i cap plus 2j cap meter per second. Immediately before it hits the vertical wall, the wall is parallel to vector j cap. Here you see x-axis, y-axis. Okay, the smooth sphere is moving on horizontal surface with a velocity 2i cap plus 2j cap. That means one sphere is moving horizontally. One sphere is moving horizontally with velocity u bar is equal to 2i cap plus 2j cap. 2i cap plus 2j cap. Okay, with this velocity one particle having mass m travel in xy plane. That is immediately here is you read the problem. All of you read the problem. All of you read the problem. Okay, a smooth sphere is moving on horizontal surface with a velocity vector 2i cap plus 2j cap. So one sphere moving with a velocity, this one 2i cap plus 2j cap means that is in first quadrant. Okay, immediately before it hit the vertical wall, and before hitting the vertical wall, it travel with the velocity this one. The wall is parallel to J cap. So wall is parallel to J cap means here parallel to this y-axis. It is the wall. Here there is a wall parallel to y-axis, or the wall is parallel to J cap. J cap is along y-axis. That's why wall is parallel to J cap means that is along y-axis, parallel to y-axis. There is a wall. The wall is parallel to vector J cap, and coefficient of resistance between the sphere and the wall is coefficient of resistance between the sphere and wall, that is equal to 1/2. The velocity of the sphere after it hits the wall. Velocity of the sphere after hits the wall, V bar is equal to question mark. You see, whenever the particle travel with a velocity this one, and while making collision with the wall, at that time the velocity component along x, here velocity component along this direction, along this direction and along this direction, velocity component in this direction is equal to 2y cap. Here in this direction it is 2j cap. Along y-axis, whenever the particle makes collision here, during collision along y-axis, is there any force acts on the body? Is there any force acts on the particle? No, because it is in a horizontal plane. So particle travel along in a horizontal plane. So in horizontal plane along y-axis there is no force acts, because these two are the smooth surfaces. The wall is smooth surface, that is mentioned in the problem. That's why along y-axis there is no change in the velocity of the particle. So even after collision also, velocity of the particle Vy is equal to, just before collision whatever the velocity of the particle along y-axis, even after collision also velocity of the particle along y-axis is equal to 2 only. But what about the normal direction? That means what about the along x-axis? Before collision, the velocity of the particle along x-axis is equal to 2i cap. Okay, after collision, definitely what is the velocity of the particle along x-axis? V1x is how much? Initial velocity along x-axis is 2. Initial velocity along x-axis 2. What is the final velocity along x-axis? Final velocity of the first particle along x-axis, V1x is equal to say Vx, that is equal to how much? Along x-axis means that is the line of impact. No, this is the x-axis acts as the line of impact. This is the line of impact. Along line of impact we can apply the Newton's law of restitution. No? According to that Newton's law of restitution, E is equal to V2x minus V1x. Final velocity of the second particle along x-axis minus final velocity of the first particle along x-axis by velocity of the first, initial velocity of the first particle along x-axis, initial velocity of the second particle along x-axis. Now we substitute the data. E means half. Of course, as the wall is rigid, we need not write this one. Whenever the particle makes collision, it rebounds with a velocity E into initial velocity. No, directly we can write. There is no need to write this formula like this. Okay, directly you write. You need not write, because wall is fixed. Wall is rigidly fixed. That's why even before collision or after collision, there is no motion in the wall. That's why we can apply directly velocity of the particle after nth collision is equal to e to the power of n into v formula is there. No, so velocity of this particle, no doubt after collision the particle rebounds back in this direction. So velocity of the first particle along x-axis, that is equal to Vx, is equal to e to the power of n, means after making only one collision, into velocity with which the particle first makes collision, that means 2 meters per second. No, so into 2. Therefore that is equal to 2e. 2 into e means 1/2, that is equal to 1. Therefore velocity of the first particle along x-axis means along negative x-axis, that is 1. Okay, along y-axis velocity of the particle is this one. Therefore velocity of the particle after collision, V bar is equal to x component of velocity into y cap plus y component of velocity into j cap. General formula is this one. You substitute the value. X component is along negative direction, whose velocity is 1. That's why minus 1 into I cap means I cap, plus velocity of the particle along y-axis is same. That's why plus 2 into j cap. So minus I cap plus 2j cap is the velocity of the particle after collision. So this is the answer. Velocity of the particle after collision is equal to minus I cap plus 2j cap. In this way you have to do. So yeah, answer is 2. Answer is 2. Answer is 2. So here the particle is projected with a velocity u bar in xy plane, and that makes collision with the wall which is parallel to j cap. J cap means that j cap is along y-axis. So The wall is parallel to j cap means wall is parallel to y-axis. With this wall, the particle makes collision. After collision, what is the velocity of the particle? They asked. Here, before collision, the velocity of the particle is 2i cap plus 2j cap. That means x component of velocity is 2i cap, y component of velocity is 2j cap. So during collision, as wall is the smooth, that is given in the problem only. As the wall is smooth, along the parallel to wall, there is no force acts, there is no friction acts on the particle. That's why before collision, along y-axis, whatever the velocity, even after collision also, along y-axis velocity remains same. But this velocity along x-axis, x component of velocity is the velocity along line of impact, because during collision at this point of contact you draw a tangent. Normal to tangent, when you draw a line perpendicular to common tangent but passing through this point, that is the line of impact. So line of impact is along x-axis. So before collision, it makes collision with a velocity 2 meters per second with this wall. Then it rebounds with a velocity Vn is equal to e to the power of n into v. Directly we can write this formula. Otherwise, E is equal to V2 minus V1 by U1 minus U2. Along line of impact, you apply that formula. In that formula, V2 and U2 are 0. V2, U2 are the velocities of the wall before, after collisions. That's why wall is not moving even after collision also. That's why V2, U2 you make 0. Then you will get this value only. So this is the velocity of the first particle along x-axis. That is say Vx. That is towards negative x-axis now. Therefore, velocity of the particle after collision is equal to x component of velocity into I cap plus y component of velocity into j cap. X component of velocity is along negative direction. That's why minus Vx means that is equal to 1 into I cap plus Vy means that is along positive y direction only. That is 2 into j cap. So this is the velocity vector of the particle after it makes collision. Okay. This is only V velocity of the particle V bar is equal to, this is V bar. V bar is equal to minus I cap plus 2j cap. Okay, Sriram. Minus I cap plus 2j cap. Okay. V bar is equal to only, this is only is equal to V bar is equal to I minus I cap plus 2j cap. Okay. Next. Okay, you see next problem. You see the next problem. A projectile is fired on a horizontal ground. A projectile is fired on a horizontal ground. Coefficient of restitution between the projectile and the ground is E. If A, B, C be the times of flight, maximum height, and horizontal ranges in first two collisions. Okay, all of you see the second problem. All of you see the second problem. A ball striking a horizontal floor at an angle of theta is equal to 45 degree with normal to the floor. Okay, here one ball strikes with a velocity u1 is equal to u1 at an angle 45 degree with vertical or with normal to the floor. The coefficient of restitution is equal to half. Sorry, coefficient of restitution is not given. A projectile is fired. Okay, sorry. The projectile is fired. All of you see the second problem. All of you see the second problem. A projectile is fired on a horizontal ground. Coefficient of restitution between the projectile and the ground is E. Then ratio between the times of flights T1 by T2 is equal to A. Ratio between the maximum heights reached H1 by H2 is equal to B. And ratio between the horizontal ranges R1 by R2 is equal to C. That is given. Okay, now What about the A value, B value, C value? They asked. What about the A value, B value, C value? Okay, you see. Now all of you look at the board. I think you have seen the problem. Now all of you look at the board. All of you look at the board. Here, one particle is projected with certain angle. One particle is projected with certain angles with a velocity u at an angle say theta, or u1 at an angle theta. Then travel along the parabolic path. Okay, before reaches the ground, definitely angle of impact is equal to theta only. This is theta only. This angle is theta only. Okay. Now in first case, time of flight t1 is equal to, we can write 2u1 sin theta by z only, no? 2u1 sin theta by z. It is the time of flight in first case. What about the time of flight in the second case? What is the time of flight in the second case? General formula here is, you see, time of flight t is equal to 2 into u1 sin theta is the vertical component of velocity before collision by z. After collision, you see, here with what angle we projected, with the same angle it makes collision here. Okay, then what about the after collision, after first collision, with what velocity it rebounces? With what velocity it rebounces? Okay, along horizontal direction, as it is a smooth surface, no change in the velocity along horizontal direction. That's why horizontal component of velocity remains same, but vertical component of velocity changes. After first collision, vertical component of velocity Vy is equal to how much? After first collision, you see, before making collision, its velocity is same as this u1 only before making collision. After first collision, along the line of impact, what about the velocity? Means Vy is equal to e to the power of n into v, no? That is equal to e to the power of n means e only. After first collision only, e to the power of 1 into v means along y-axis with what velocity it makes collision, means that is equal to u1 sin theta, no? Because with what vertical velocity here, whenever it is projected with a velocity u1, their vertical component of velocity is u1 sin theta, horizontal is u1 cos theta. Before it reaches the ground, the vertical component of velocity does not change. That is u1 sin theta only. So with what velocity it rebounces? With what velocity it rebounces means with along vertical direction it rebounces with a velocity say vy after first collision. So vy is equal to e into u1 sin theta. Therefore, in this case, what is the time of flight? Time of flight t2 is equal to 2 into vertical component of velocity after collision. That means 2 vy by z. That means after first collision, what is the time of flight for the body to reach the ground again? That is equal to 2 into vertical component of velocity after first collision, which is equal to this one. 2 into this velocity eu1 sin theta by g. Okay, therefore t1 by tt is equal to how much? T1 by tt is equal to, you see, divide these two equations. This is equation 1, it is equation 2. Divide these two equations. This by this means you will get 1 by u only, no? Because 2u1 sin theta by z, 2u1 sin theta by g cancel. So t1 by tt is equal to 1 by e. But t1 by tt is given as a. That's why this is equal to a. So a is equal to 1 by e. A is equal to 1 by e. That is the, okay, first option is correct. First option is correct. Next, what about the maximum heights reached? What about the maximum height reached in this case? Next, option B. Second option, here they asked a ratio of the maximum heights reached. In second option B, it is the first option. We proved the first option. Second option B, you see, ratio between the maximum heights they asked. Ratio between the maximum heights is given as B. B is equal to h1 by h2. You see, B is equal to h1 by h2. What about h1, h2? Before making first collision, maximum height reached is equal to vertical component of velocity square, no? u1 square sin square theta by 2z. After collision, maximum height reached is equal to 2 into vertical component of velocity square by, sorry, vy square by 2z. Okay, 2z cancel. Therefore, u1 square sin square theta by vy square means this one. Vy square means E square into U1 square sin square theta. U1 square sin square theta, U1 square sin square theta cancels, so 1 by E square. Therefore, B is equal to 1 by E square. This is the ratio between the maximum heights reached. Okay, next C. Ranges ratio. C is equal to ratio between the ranges R1 by R2. R1 means U1 square, E1 square sin 2 theta by G by here R2 square means R2 means U2 square sin 2 theta by G. Or in other words, you write like this. You see here range R is equal to, but range R is equal to U square sin 2 theta by Z. That is equal to U square into sin 2 theta can be written as 2 sin theta into cos theta by Z. Okay, this is equal to 2 into U sin theta into U cos theta. U sin theta into U cos theta by Z. Okay, but here whenever the collision takes place along horizontal direction, there is no change in the velocity. That's why horizontal component of velocity remains constant even after collision. G is constant, 2 is constant. That's why range is directly proportional to vertical component of velocity only, no? So in two cases, before making first collision, range R1, second collision R2 anukunte, that is equal to before making first collision, the vertical component of velocity of the body before making collision by vertical component of velocity after collision. Before vertical component of velocity after collision, Vy. So before collision, what is the vertical component of velocity? After collision, what is the vertical component of velocity? Before collision, vertical component of velocity is u1 sin theta. After collision, vertical component of velocity is eu1 sin theta. eu1 sin theta. u1 sin theta, u1 sin theta cancels, therefore 1 by e. So C is equal to 1 by e. It is the ratio between the ranges in the two cases. C is equal to 1 by e is correct. So A, B, C are correct now. In the given options, you see A, B, C are correct. I think you are having books. You go through that books. You see, in second problem, we got A option, B option, C option also. So all the above are correct is the answer. First option, second option, third option are not correct. Fourth option is correct. Okay, because A, B, C are first, second, and third options are correct. That's why we have to write all the above are correct. All the above are correct. That is the answer. Okay. Option D is correct, Karthik. Very good. Option D is correct. Here time of flight is equal to, you see general formula for time of flight means 2 into u1 sin theta means that is vertical component of velocity, no? U sin theta is the vertical component of velocity. So vertical component of velocity by Z. It is the first case. In second case, after collision, what is the vertical component of velocity? After collision, vertical component of velocity is eu1 sin theta, no? That's why 2 into vertical component of velocity after collision by Z. That is the time of flight in second case after first collision. Vy means I have substituted this one, eu sin theta by Z. Okay. Right. Next. Next one is very, very important. Shall I erase? Shall I erase this one? Shall I erase? Yeah. Sriram, time of flight means 2 into vertical component of velocity by Z. 2u sin theta by Z. U sin theta ante vertical component of velocity kada. C. ఇక్కడ చూడండి, range R is C కాన్సెప్ట్ మళ్ళీ చెప్తున్నాను. Range R is equal to ranges మధ్య రేషియో కదా C అంటే. C means that is the ratio between the ranges. Range is equal to u square sin 2 theta by Z, or u square into sin 2 theta can be written as 2 sin theta cos theta. 2 you keep aside, u split them, u sin theta into u cos theta you write. Here U cos theta is the horizontal component of velocity. Here, whenever the body is projected here, along horizontal direction, even collision takes place. This is the smooth surface. That's why even during collision also, along horizontal direction on the projectile, no force acts. Whenever no force acts on the projectile along horizontal direction, the horizontal component of velocity does not change even during collision. కొలిజన్ జరిగే టైంలో కూడా హార్జెంటల్ డైరెక్షన్ లో ఏ ఫోర్స్ పనిచేయట్లేదు కాబట్టి, ఫ్రిక్షన్ పనిచేయట్లేదు కాబట్టి, దానికి వెలాసిటీ హార్జెంటల్ డైరెక్షన్ లో కొలిజన్ జరిగిన తర్వాత కూడా మారదు. కాబట్టి బిఫోర్ అండ్ ఆఫ్టర్ కొలిజన్ along horizontal direction velocity component is same. That's why u cos theta is constant. 2 already constant, g constant. అప్పుడు vertical direction u sin theta అంటే vertical component of velocity no. Before collision vertical component of velocity is u1 sin theta. After collision vertical component of velocity is u1 sin theta. That means only vertical component of velocity changes. That's why vertical component of velocity only variable. That's why range is proportional to vertical component of velocity only. No, there are two cases. C is equal to r1 by r2. That is equal to, in first case, vertical component of velocity before collision by vertical component of velocity after collision, because these are the ranges before collision and after collision. Before collision vertical component of velocity u1 sin theta. After collision vertical component of velocity we got e into u1 sin theta. u1 sin theta, u1 sin theta cancel, therefore 1 by e. 1 by e is the answer. Okay. Right. Next. Okay, next you see, next problem. Third problem, I will say the concept because one more example is there. That example I have to teach. I have to say. Okay. Next. You see, what about fourth problem? Shall I explain fourth problem or no need? Fourth problem. Fourth problem, you see. Fourth problem. Okay. Fourth problem. A particle of mass, all of you see the problem. A particle of mass m, initially at rest, is acted upon by a variable force F for a brief interval of time t0. It is moving with a velocity u. After the force stops acting, then u is dash. Area under the graph is equal to, you see, force acts on the body which varies with time on a body given like this. Before the force acts on a body, it is the semicircle. Before the force acts on a body, the velocity, whatever the velocity of the body that is given, that is initial velocity of the body. Sorry, initially it is at rest. So initial velocity of the body is 0. The force acts on a body which varies with time according to the graph like this. And whenever force stops acting on the particle, means after t0 seconds, the force acts on the particle after t0 seconds. So after t0 seconds, force stops. At the time, the velocity of the body v is equal to u. That u is equal to question mark. That is the case. That means here you see, as the semicircle force varies with time according to the semicircular fashion, the area under the semicircle we can calculate now. Area under graph gives impulse. Area under ft graph gives impulse. Ft graph gives impulse. That is equal to area under ft graph is equal to change in momentum mv minus mu. Okay. Here area under the graph is equal to integral f into t, because the force is not constant. Force varies with the time. That's why you write integral ft. That is equal to total change in momentum mv minus mu. So area under ft graph means integral f into t, which is equal to impulse, because this time is given as short time. That's why it is impulse. Impulse is equal to area under the ft graph. That is equal to change in momentum. So what is the area under the graph? It is the semicircle. As it is the semicircle, area of the semicircle means pi r square by 2, no? Pi into r square by 2. R square means one radius you take along x-axis, another radius you take along y-axis. Rx into ry. One radius is taken along x-axis, one radius is taken along y-axis. That's why as both are equal, pi into r means pi r square. Pi r square by 2 is the area of the semicircle. Okay, this is equal to m into final velocity of the body v minus initial velocity 0. That's why initial momentum 0. Pi into rx. Rx means, you see, radius of the semicircle along x-axis means this total time up to this, it is equal to diameter, that is equal to t naught. Half of the diameter is the radius, no? That is equal to t naught by 2. ఈ టోటల్ డిస్టెన్స్ లో హాఫ్ అంటే టీ నాట్ బై 2నే కదా, ఆర్ఎక్స్ టీ నాట్ బై 2. ఆర్వై అంటే డైరెక్ట్ గా ఇక్కడ వాల్యూ ఎంత ఉందో చూడండి ఒకసారి డయాగ్రామ్ లో. Here exactly at this maximum position, the force is given as f naught. That's why this length is equal to f naught only. This is the radius along y-axis. So rx means that is t naught by 2 into ry means f naught whole by 2, that is equal to m into v. Therefore, velocity of the particle after force stops acting on the particle, v is equal to this by m, pi f naught t naught, pi f naught t naught by 2 into 2, 4m. So pi f naught t naught by 4m. Pi f naught t naught by 4m. That is the answer. So third option is the answer. Okay. In this way you have to do. Next. Fifth problem, you see, that is also important one, but easy. Fifth problem. How r came? R is substituted here, no? One radius you take along x-axis, one radius you take along y-axis, because along x-axis, y-axis, different physical quantities are taken, no? That's why you take the here area of the semicircle means pi r square by 2. That pi r square by 2, in this pi r square by 2, one radius is taken along x-axis, one radius is taken along y-axis. By 2 I have written. Okay, Revan, okay. So you see the problem? You see the board clearly? Fifth model is important. Fifth model is important. I will say collision with the friction problems also. I will say few problems are there. If in this in our material, if problems are there, okay. Otherwise, I will say from other books. Okay. Next, fifth problem. All of you see the fifth problem. You see fifth problem. A ball of mass m. Sorry. A particle of mass m moving in x direction with a speed 2v is hit by a particle of mass 2m moving in y direction with a speed v. Okay, here one particle moving along x-axis. Here you see one particle having mass m1 is equal to m moving with a speed 2v along x-axis initially. Another particle of mass m2 is equal to mass m2, that is equal to 2m moving with a velocity along y direction with a velocity v. So u2 is equal to v. U2 is equal to v. These are the velocities given. Okay, now if the collision is perfectly inelastic, the percentage loss of energy during the collision is dash. Okay, you see, before collision, have you seen the problem? Have you seen the problem? Okay. Now you see the board clearly. You see the board. One particle of mass m moving with a velocity 2v along x-axis, another particle of mass 2m moving with a velocity v along y-axis. Both are moving in different directions before collision. After collision, the two particles stick together and travel with certain velocity. After collision, as the collision is inelastic, definitely after inelastic collision, the two particles stick together. No, after collision, with what velocity two particles travel? Because after collision, as the two particles merge together, coalesce each other, stick together, combine together, and travel with common velocity. What is that common velocity you find? Before collision, total kinetic energy of the two particles we know, we can calculate. After collision, as the two particles travel with common velocity, we can find the kinetic energy of the system after collision. So what is the percentage loss of kinetic energy? I think we can calculate. Okay. So here you see, after collision, what is the velocity we have to find? As before collision, as the particles travel in different directions, we have to apply the law of conservation of linear momentum in vector form. Before and after, before collision, as the two particles travel in different directions, they are not travel along the same direction before collision. That's why we have to apply the law of conservation of linear momentum in vector form. We have to apply the law of conservation of linear momentum in vector form. Okay. Ade, before collision and after collision, if the particles travel along the same straight line path, then we can use the law of conservation of linear momentum directly in scalar form. M1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But here, before collision only, the particles travel in different directions. That's why you have to apply the law of conservation of linear momentum in a vector form. According to law of conservation of linear momentum, m1 u1 bar plus m2 u2 bar is equal to m1 v1 bar plus m2 v2 bar. m1 means m into u1 bar means 2v. 2v into I cap, because this particle travel along positive x-axis. Generally, it is x-axis, it is y-axis. Okay. Plus m2 means 2m into u2 means v into positive j cap. It is the moment of the two particles before collision. After collision, as the two particles combine together, because collision is inelastic. That's why after collision, as the two particles combine together, the two particles can be treated as a single body of mass m1 plus m2 into their common velocity, say common velocity vc bar, because we substituted in vector form. So you have to write it in vector form only. Now 2mv I cap plus here also 2mv j cap is equal to m1 is m, m2 is equal to m. That's why it becomes 3m. 3m into vc bar. M that can be cancelled in all. Then common velocity vc bar is equal to 2v I cap plus 2v j cap whole by 3. 2v by 3 we can take common now. 2v by 3 into I cap plus j cap we can write. I cap plus j cap we can write. What is the magnitude of this common velocity? Magnitude of common velocity. Common velocity is equal to magnitude of this one. That means modulus of this one. 2v by 3 you write as it is. Modulus of I cap plus j cap means root 2, no? That's why 2 root 2 v by 3. It is the common velocity. Here, what is the percentage loss of kinetic energy? They asked. Percentage loss of kinetic energy we have to find out. Percentage loss of kinetic energy means, as inelastic collision takes place, definitely there is a percentage loss of kinetic energy. What is the percentage loss of kinetic energy? So percentage loss of kinetic energy means, first, initial kinetic energy of the system of two bodies is how much? Initial kinetic energy of system of two particles is how much? Half m1 into u1 square plus half m2 into u2 square. Okay, this is the kinetic energy of the two particles before collision. That is equal to half m1 means m into u1 square means 2v whole square, so 4v square, plus half m2 means 2m into u2 square means v square. Here 2 cancel, here 2 2s are 2mv square plus mv square, that means 3mv square. It is the initial kinetic energy of the system before collision. After collision, what is the kinetic energy of the system? That means final kinetic energy of the system after collision. After collision, as the two particles move together, the total kinetic energy of the system after collision is equal to half into total mass of the system into common velocity square. That is equal to half into m1 is m, m2 is 2m. That's why 3m into common velocity square means this square. This square means 2 root 2 v by 3 whole square. Okay, so this is equal to 3m by 2 into, when you square them, then you will get 8 v square by 9. 2 4s are 3 3s are. Okay, therefore 4 by 3 m into v square. It is the total kinetic energy of the system after collision. Therefore, percentage loss of kinetic energy. Percentage loss of kinetic energy means loss of kinetic energy by initial kinetic energy into 100. That means initial kinetic energy minus final kinetic energy by initial kinetic energy into 100. Suppose if they ask percentage change in the kinetic energy, if they ask in such case final kinetic energy minus initial whole by initial into 100, we have to write. But definitely there is a loss of energy. That's why you write directly, as they asked the loss of energy only, you write initial kinetic energy is greater. So EI minus EF by EI into 100. Split them. When you split them, EI by EI minus EF by EI. So 1 minus EF by EI into 100. So 1 minus EF means, EF is this one, 4/3 mv square by EI means 3 mv square into 100. So therefore this is equal to delta E by E into 100 is equal to, you see mv square cancel. Okay, next 1 minus 4 by 9, 1 minus 4 by 9 into 100, that is equal to 5 by 9 into 100. No, is it correct or not? 1 minus 4 by 3 into 3 9, 1 minus 4 by 9, 9. When you take LCM, 5 by 9 into 100 you will get, that is equal to 500 by 9. That is equal to, after simplification, what you will get? 9 4s are 45, 50. 9 4s are 45.50. 4s are, you will write, sorry, 9 5s are 55 point something you will get. 9 5s are 45. 9 5s are 45. Remainder is 5. 5 0 50. 9 5s are 45. 9 5s are like that you will get. Okay, this is equal to approximately, based on the answer you round off the value. Nearer to this one, 56 is there, no? So we can round off to 56, because when you remove this 5, you will get 6 and we can delete this one. As it is greater than 5, definitely you can delete, and by increasing the preceding value by 1. So 56 you will get approximately 56. So percentage loss of kinetic energy is, 56%. In this way you have to do. Yeah, 55.555 something you will get. So approximately 56. Okay. Next. Sixth one. I will say first sixth one, later I will explain seventh problem. Okay. Sixth one, no, it's not same model. The ball strikes with the floor. The ball strikes with the floor. That is the different model only. But I said the concept. After collision, what is the velocity of the body? We have to calculate. How we can find? I explained already. This problem or that problem, not same model, but concept is same. Change in kinetic energy, we had percentage change in kinetic energy we have to find. Sorry, fraction of loss of kinetic energy we have to find. Shall I write this one? Yeah, last one, same formula. In this way only we have to find. Shall I erase? Okay, now you see the sixth problem. You see sixth problem. Sixth problem. A ball strikes a horizontal floor at an angle of 45 degrees with normal to the floor. Sixth problem. A ball strikes the A ball strikes the horizontal floor with an angle 45 degree, with the normal to the floor. Coefficient of resistance between the ball and floor, that is equal to 1/2. The fraction of its kinetic energy lost in the collision. Fraction of kinetic energy lost. That is the question they asked. Okay. Now all of you see the board. Here, a ball strikes a horizontal floor. At an angle 45 degree with a normal to the floor. So whenever the particle strikes at this point, then at this point of contact, you draw a common tangent. Common tangent is the floor only. So perpendicular to common tangent is in this direction, normal is in this direction. That normal is the line of impact. So normal to the inclined plane, that means that is vertical in the diagram. With vertical, the ball makes an angle 45 degree, and with this angle, it makes collision with the floor. While colliding the floor, it is like this. After collision, what about the velocity of the body? Here, so after collision, what about the velocity of the body? Here, this is, you see, before collision, velocity component along x-axis. Suppose the velocity with which the ball is thrown against the floor is say u. So before collision, velocity of the body along x-axis is u sine 45 and along y-axis u cos 45. That means along line of impact, the ball makes collision with the floor with a velocity u cos 45. Before collision or after collision, there is no motion for the floor. The floor is still at rest only. That's why normal to the floor, it makes collision with the velocity u cos 45 and rebounds with the velocity vy. It is the initial velocity along y-axis. Final velocity after collision along y-axis is how much? Final velocity along y-axis means that is along the line of impact only, no? Along line of impact, with what velocity the ball rebounds along the line of impact. That means along line of impact velocity is equal to E into U cos 45, we can write now. Along line of impact, ఇది ఎంత velocity collision జరిపిందో మళ్ళీ E times velocity తో rebounds అవుతుంది along line of impact. But along horizontal direction, as no friction is given in the problem, definitely along horizontal direction, its velocity does not change. So even after collision also, along horizontal direction, it has velocity same as the velocity along horizontal direction before collision. That's why this is equal to u sine 45 only. Therefore, this is equal to E into u by root 2 along y-axis. Along x-axis, velocity component is u into sine 45, means u by root 2. U by root 2. Here, you see here, E means 1/2 is given now. So u by 2 root 2. Therefore, result net velocity of the projectile, net velocity of the ball after collision, that is say v. So v is equal to square root of x component square plus y component square. That is equal to square root of x component square means u root 2 whole square. U root 2 whole square plus y component square means u by 2 root 2 whole square. When you square on both square here, then u square 2u square plus u square by 8 you will get. When you take LCM, then you will get root 17 u square by 8. It is v value. Okay, so that is equal to root 17 by 8 into u we can write, or v by u is equal to, we can write root 17 by 8. So we got this relation. Now, what is the fraction of loss of kinetic energy? They ask now. The fraction of kinetic energy lost. Fraction of kinetic energy lost means loss of kinetic energy by initial kinetic energy of the system. Loss of kinetic energy means initial kinetic energy minus final kinetic energy by initial kinetic energy. It is the fraction of loss of kinetic energy. When you split them, 1 minus kf by ki, you will get no 1 minus kf by ki. 1 minus kf means final kinetic energy, half m into final velocity square by half m into initial velocity square. So this is called 1 minus v square by u square, you will get 1 minus v by u is this one. V square minus u square means you will get 17 by 8, no? 17 by 8. Is it correct or not? Is it correct or not? Sine Vx is equal to u by root 2, where, yeah, here u by root 2. X component of velocity is u sine 45 means u by root 2, no? U by root 2. Here by root 2, not into. Okay. Okay, here we see square root of u square by 2 plus u square by 8. Okay, that is equal to square root of, when you take 8 LCM, then 5 u square you will get. Okay, so this is equal to u into root 5 by 8, or v by u is equal to root 5 by 8. Okay, therefore here 1 minus m by 2 cancel, v square by u square, that is equal to 1 minus v square by u square means 5 by 8 only, no? 5 by 8. Therefore fraction of kinetic energy lost is equal to simply 3 by 8. Fraction of kinetic energy lost is equal to 3 by 8. First option is the answer. Yeah, 3 by 8 is the answer. Vikyat, very good. Revan, right. Bala Aditya. Okay. Vamshi Krishna, 3 by 8 is the answer. Okay, seventh problem somebody else asked. That is important problem also. Okay. Seventh problem, is it given to you for homework? No, somebody else asked me. That means they were unable to get the answer, I think. Shall I explain seventh problem or no need? Shall I explain seventh problem or no need? Okay, now you see the seventh problem. Seventh problem you see. Seventh problem. All of you see the seventh problem. Okay, seventh problem you see. A sphere of mass. Seventh problem. A sphere of mass 1 kg moving with a velocity 4 I cap minus j cap. It hits a wall and rebounds with velocity I cap plus 3j cap. I cap plus 3j cap. Okay, the coefficient of restitution between the sphere and the wall is dash. Okay. Yeah, wall velocity of the wall is not given means it is stationary only. Velocity of the wall is not given means it is stationary only. Okay. A sphere of mass 1 kg. A sphere of mass 1 kg is moving with a velocity 4 I cap minus j cap means here you see initially the particle or the sphere moving with a velocity u bar is equal to 4 I cap minus j cap is given. Suppose you take this as x axis, this as y axis. Definitely the particle is moving like this only, no? The sphere is moving like this only, no? Then only their x component is positive, y component is negative. If the particle or ball moving in this direction, then only their x component positive, y component negative you will get. Okay, like this the particle is moving. It hits a wall and rebounds with a velocity I cap plus 3j cap. It hits the wall. Suppose this is a wall. This is a wall. Of course, wall need not be perpendicular to x-axis. Wall need not be perpendicular to x-axis or perpendicular to y-axis. Okay. Here it hits the wall and it rebounds with a speed I cap plus 3j cap. I cap plus 3j cap. So here you see The wall is not parallel to x-axis. The wall may be in another direction. Here along which direction wall is there, that is not mentioned, no. It hits the wall and rebounds with a velocity I cap plus 3j cap. No doubt here some wall is there. The wall may be any direction, we cannot say. But after collision with wall, it is the wall. After collision with wall, it rebounds with a velocity v bar, that is equal to, no doubt after collision x component is positive, y component is positive. Suppose this is y component is positive. This is this is y axis, it is x axis. After collision, the particle travel along this direction so that their x component positive, y component positive. That velocity is given I cap plus 3j cap. It is given. Okay, now what is the coefficient of restitution? What is the coefficient of restitution? That is the question they asked. No doubt change in momentum takes place. Change in momentum takes place only along line of impact. This is say wall. This is the wall. Perpendicular to the wall. Suppose whenever the particle makes collision here, perpendicular to the wall, if you draw a normal, along this direction it is the line of impact or it is the normal. Along this direction only change in momentum takes place. Parallel to the wall, there is no change in the momentum. Parallel to the wall, there is no change in the momentum. Okay, that is given. So here change in momentum take place only along this normal. Only along this normal. We are given, you see, what is the impulse received by the body along this normal? What is the impulse received by the body along the normal direction? Means you write in vector form. You see, impulse received by the ball, impulse received by the ball along this normal direction is equal to impulse is received by the normal reaction only. That's why normal reaction into time. It is the integral n into dt is the impulse received by the ball along normal to the wall or along line of impact. Parallel to the wall, there is no change in the momentum because parallel to the wall, friction is not given. Is friction is given in the problem? I think friction is not given. Friction is not given. That's why parallel to the wall, there is no friction. That's why parallel to the wall, there is no change in the velocity. There is no change in the linear momentum also. Whenever there is no change in velocity, there is no change in the momentum also parallel to the wall. Only normal to wall or along line of impact only because of collision, because of force acts on the ball along normal to the wall or along line of impact, there is a change in momentum. Change in momentum, you write in vector form because before and after collision, the body travel with different velocities in different directions. That's why this ball receives or sphere receives the change in momentum only along impulse direction or along line of impact. So along line of impact, impulse received is equal to final momentum minus initial momentum. Final momentum means mass into final velocity minus mass into initial velocity. That is the change in momentum. Change in momentum is taken place only along line of impact, no other directions. So m means you write 1 you take m common, m of v minus u bar. So m1 into v bar, I cap plus 3j cap minus u bar means minus of 4 I cap minus j cap. Okay, therefore impulse received is equal to integral n into dt. That is equal to I cap minus 4 I cap means minus 3 I cap and plus 3j cap minus or minus plus 3j cap plus j cap means plus 4j cap. This is the impulse received by the particle along line of impact. That means definitely normal to the wall is in this direction. That's why normal to the wall is in this direction means definitely wall is in this direction. So direction of the normal to the wall is in this direction. Okay, now what is the coefficient of restitution they asked? Okay, you see, normal to the wall, what is the velocity component? First we have to find. Normal to the wall, what is the velocity component? We have to find first. Before collision, normal to the wall, what is the velocity component or what is the momentum? After collision, what is the momentum component? What is the momentum of the body after collision along normal to the wall or along line of impact? We have to find first. Okay. So we got the total change in momentum is this one. Total change in momentum is this one. Okay. Now how we can find the component of the velocity along normal to the wall? We have to find. What is the magnitude of velocity before collision? What is the magnitude of velocity before collision? That is equal to u is equal to root 17. No. After collision, what is the magnitude of velocity? Root 10. No. So what is the angle made by this velocity with the normal to the wall? This is the angle with which it makes collision with the wall. The angle with which the direction of motion of the particle makes with vertical before it makes collision. That is theta. How we can find that theta value? What is the value? You see, along y-axis, change in momentum along y-axis is equal to x-axis is equal to 4i cap. Velocity along change in velocity along x-axis is 4i cap minus i cap, means 3i cap. Along y-axis, that means 3i cap is the change in velocity along x-axis. So change in momentum along x-axis is equal to mass into change in velocity along x-axis. Mass into change in velocity along x-axis. Okay. Anybody else got idea? Tan theta slope. Okay, how we can write tan theta? Y by x we can write. That means 1 by 4. This angle is tan theta. No. With x-axis, angle made with x-axis is tan theta is equal to 1 by 4. Not with this normal. Not with that normal. Root 17. Okay, you keep like this. In next class, I will explain, or in evening study hour, I will send the solution to you. Okay, next, what is the next problem? You see, you leave here. Here actually you will get coefficient of restitution is equal to 9 by 6 you are given. Coefficient of restitution is equal to 9 by 16 given. Actually, we have change in momentum. No? Change in momentum along normal to the wall we calculated. By these velocities also, we have to find the change in momentum along this normal to wall or line of impact. You make them equal to this one. You make them equal to this one. Then you will get answer. But here we have to find this angle also. This angle. Initial angle we know. Initial angle we know. Then what about this angle? If you know this value, then velocity component along line of impact before collision we know. After collision we can find. Then if you know that value, then we can calculate the change in momentum along line of impact in terms of coefficient of precipitation E. You make them equal to minus 3i cap plus 4j cap. Then you will get E value. But how we can find this E? That is important here. I think you see change in momentum we got no. Change in momentum is along line of impact only. This angle we know, I think this angle we can find, because angle made by this change in momentum is always along line of change in momentum is always along impulse received by the body. That means along line of impact only. Along this direction only J impulse is there. Impulse J bar is there. Angle made by this J bar with Y axis, because we have taken this as Y axis, this as X axis, because we are given velocities in I cap, J cap. That's why it is Y axis, it is X axis. This angle is say alpha. Then what about alpha? Tan alpha is equal to Y by X. No, tan alpha is equal to Y component by X component. So here angle made by this impulse direction with Y axis is equal to angle made by this with Y axis is equal to X by Y. No, X by Y. X component is equal to 3. Y component is equal to 4. That's why this is equal to 3 by 4. 3 by 4 means alpha is equal to, we can write 37 degree. No, so this is equal to 37 degree. What is the angle made by this initial velocity with Y axis? Angle made by initial velocity with Y axis. What is the angle made by initial velocity with Y axis? Angle made by initial velocity with Y axis is equal to, initial velocity is here 4i cap minus j cap. Okay, angle made by this initial velocity with Y axis is equal to X by Y means 4 by 1. This angle is known, this angle is known. So sum of these two is the total angle between line of impact and this velocity direction. Okay, we'll see later. We see later. If you do dot product between them, can we find? Because in this direction velocity is known, in this direction velocity is known. If you do the dot product, I think we can get the angle between these two. No. Okay, we see later. By doing dot product between this velocity vector and this impulse this impulse received by the body, ఈ రెండిటి మధ్య డాట్ ప్రొడక్ట్ చేస్తే, ఈ రెండు మధ్య డాట్ ప్రొడక్ట్ అంటే ఇక్కడ యాంగిల్, ఈ రెండు మధ్య యాంగిల్ థీటా అనుకోండి, అప్పుడు యూ కి జే బార్ కి మధ్య యాంగిల్ 180 మైనస్ థీటా. సో ఏ బార్ డాట్ బి బార్ ఇస్ ఈక్వల్ టు ఏబి కాస్ థీటా, థీటా ఇస్ ఈక్వల్ టు 180 మైనస్ థీటా, యూ హ్యావ్ టు రైట్ 180 మైనస్ థీటా. ఓకే, బై డూయింగ్ డాట్ ప్రొడక్ట్ యూ ఫైండ్ ద యాంగిల్. వెన్ యూ నో యాంగిల్, this angle, then momentum of the body before collision along line of impact we can find. Momentum of the body after collision along line of impact we can find. So you find the change in momentum along line of impact, you make them equal to this one. I think you will get. Okay, in evening study hour I will send the solution to you, you go through them. Right, next one. Next, first problem you see. All of you see in level 2, first problem. Level 2, page number 46, first problem. That is also important one. A ball is falling vertically downward with a velocity v1. It strikes elastically with a wedge moving horizontally with a velocity v2 as shown. what must be the ratio V1 by V2 so that the ball bounces back vertically upward relative to the wedge? Okay, all of you see the board now. All of you see the board. Here it is the wedge. Wedge is moving with a velocity V2. Wedge is moving with a velocity V2 towards left. One particle is dropped. One particle is moving with a velocity vertically downwards. One particle is moving with a velocity V1 vertically downwards. The particle A moving vertically downwards with a velocity V1 with constant velocity V1. Okay, now what must be the ratio V1 by V2 so that the ball bounces back in vertically upward direction? Okay, relative to the wedge. This is the wedge. What is the initial relative velocity? Initial relative velocity of the body with respect to wedge is equal to how much? Initial relative velocity before collision, UBW bar is equal to UB bar minus UW bar. Initial velocity of the ball minus initial velocity of the wedge. Okay, here you see initial relative velocity of the ball with respect to wedge. What is the direction? Velocity of the ball is in downwards direction. Velocity of the wedge is in this direction. Relative velocity of the initial velocity of the ball is V1 bar minus velocity of the wedge is V2 bar. V2 bar. Okay. So velocity of the ball with respect to wedge, that means initial relative velocity of the ball with respect to wedge. What is the direction? V1 bar plus V1 bar plus minus V2 bar. Okay, suppose if you take V1 bar in this direction. If you take V1 bar in this direction, now you take the minus V2 bar in this direction. Because when you reverse the velocity V2 bar direction, then you'll get in this direction. Then it is the relative velocity of ball with respect to initial relative velocity of ball with respect to wedge is equal to V1 bar plus minus V2 bar means this one, you know. That's why this gives the relative velocity of ball with respect to wedge. Relative velocity, initial relative velocity of ball with respect to wedge is in this direction. But after collision, velocity of the ball with respect to wedge must be along vertically upwards. Velocity of the ball with respect to wedge must be vertically upwards after collision. That is given in the problem. That is given in the problem. Okay. So in this case, what about the ratio between V1 and V2? That is the question. What about the ratio between V1 and V2? That is the case. So velocity of the ball with respect to wedge after collision, that must be along vertical direction, means after collision there should not be any horizontal component of velocity. The velocity of the ball with respect to wedge after collision must be having vertical component only. Vertical component of velocity only. Okay. You see here with respect to wedge, when you consider the velocity of the ball with respect to wedge, then the wedge can be imagined to be at rest momentarily. And relative velocity of the ball with respect to wedge, when you consider, the wedge can be treated to be at rest. Whenever it is at rest, the ball with respect to wedge travel in this direction. Suppose you draw the normal to the inclined plane. Then by making some angle theta with normal to the inclined plane, normal to the inclined plane is the line of impact. So along line of impact, with line of impact, the body makes an angle, some angle, and it travels in this direction. After collision, it rebounds back. It rebounds in this direction. Okay, in this case, what about the angle? This angle is given as 30 degree. So this is also 30 degree. This is also 30 degree. Okay. As it is normal to the inclined plane. Definitely it is 60. When it is 60, as this and this both are perpendicular, this becomes 30. This becomes 30. Okay, now what about we have to find the ratio between V1 and V2, means we must know this angle. If you know this angle, V1 by V2 we can calculate easily. This angle is to be known. How we can find that angle? What is the type of collision takes place here? as they ask, what is the type of collision? Elastically. You see, in the problem, the type of collision takes place is given as elastic collision. In elastic collision, already we know the angle of collision and angle of rebounds both are same now with normal. Already yesterday we observed whenever a ball makes collision with the floor, it rebounds with a velocity, say, with angle alpha, angle of incidence is equal to theta. Then we got tan alpha is equal to some tan theta by E we got. As the collision is elastic, E is equal to 1, then alpha is equal to theta, no? That means with normal to the with line of impact or with normal to the plane, with what angle the body makes collision, with the same angle it rebounds. With what angle it rebounds, that is known from the given data. That's why angle of incidence is also same, no? That means this is also 30, no? As this is 30, this is 30, definitely these two are perpendicular. That's why this must be 30. This must be 30-degree angle. So in this right angle triangle, angle is known. Opposite to this angle V1, adjacent to this angle is equal to V2 in magnitude. Then you take tan 30. Therefore, from the diagram, tan 30 is equal to V1 by V2. Tan 30 is equal to opposite by adjacent, means V1 by V2. So V1 by V2 is equal to 1 by root 3. We can write now 1 by root 3. This is the answer. 1 by root 3. Yeah, it was previously asked bit, that is important one. Okay. No, Sidhu, we consider the relative velocity of the ball with respect to wedge. So wedge can be imagined to be at rest. When wedge is imagined to be at rest, then with in what direction the ball seems to be travel before collision? Before collision, when you consider the relative velocity of the ball with respect to wedge, then the ball seems to be traveled along this direction with respect to wedge. After collision, మనం relative velocity consider చేసాం కాబట్టి wedge can be imagined to be at rest. Ground నుంచి observe చేస్తే motion లో ఉంటుంది. But with respect to wedge, when you observe the velocity of the ball, it is travel in this direction. But actually, the ball travel along this direction. But with respect to wedge, when you observe, the ball seems to be travel along this direction. As the collision is elastic, with what angle it makes collision, with the same angle it rebounds. Angle of rebounds we know. That's why angle of incidence is also same. If it is 30, it is 30. If it is 30, definitely as the angle between these two is 90, sum of these two is 60. So definitely this angle is 30. So in this right angle triangle, tan 30 is equal to V1 by V2. So we can have. Okay. Yeah, because of collision, some momentum is transferred. Suddenly, redistribution of momentum takes place. The phenomena in which there is a sudden exchange of momentum takes place or sudden redistribution of momenta takes place, such phenomena is called, such interaction is called the collision. That is the fundamental definition of the collision. Okay. But there is no use of momentum. Yeah, in this case, finding momentum is there is no use, because just by relative velocity concept only, as we know the angles, directly by using that one, we can find the this ratio between V1 and V2. There is no need in this problem. Along which direction momentum is conserved? Tell me. We can apply the Newton's law of restitution along normal to inclined plane, because normal to inclined plane, that means this one is the line of impact. Along this direction, we can apply the Newton's law of restitution. E is equal to V2 minus V1 by U1 minus U2. Along the inclined plane, parallel to inclined plane, there is no friction. That's why we can apply the law of conservation of linear momentum parallel to the inclined plane at the moment whenever collision occurs. After some time means because of gravity, definitely velocity changes, but at the instant whenever collision occurs, at that time we can apply the law of conservation of linear momentum along incline and perpendicular to incline also. But here there is no need of finding momentum. Just they asked the ratio between the velocities. Directly we can do. Okay. Next, second problem. All of you see the second problem. Some of the students asked me yesterday. Second problem. You see second problem. Second problem. All of you read the second problem. All of you read the second problem. Second problem. A ball of mass m just disturbed from the top of a fixed smooth circular tube of radius a in a vertical plane and falls impinging on the ball of mass 2m at the bottom. Question of distribution is 1/2. Find the heights to which the balls rise after a second impact. Okay, I think you have seen the problem. Now all of you look at the board. All of you look at the board. Here there is a vertical smooth tube. A vertical fixed tube is there like this. It is the bottom. It is the center of the tube. Okay. One sphere is at the top of the tube. Another sphere is at the bottom of the tube. Another sphere is at the bottom of the tube. Okay. The sphere have at the top is having mass m. The bottom sphere is having mass m2 is equal to 2m given. Okay, now a ball of mass m is just disturbed from the top position of the vertical tube, smooth vertical tube. Then it comes down like this. As it is a smooth tube, because of gravity only it falls. Before reaching the lowest point, before reaching this position, what is the velocity acquired by this ball? That velocity say u1. u1 is equal to, tell me, whenever the ball comes from this position to this position because of gravity, what is the speed acquired by this body along horizontal? That is equal to root 2gh only, no? Root 2gh. H means that is equal to root 2z into h means whenever the ball comes from this position to this position, what is the distance fall? That is equal to twice the radius, no? So h is equal to 2r. That is equal to root 2 into root gr. 2 into root gr. It is the velocity with which the ball makes collision with this sphere, second sphere. So here collision takes place between them. So at lowest point, whenever the first sphere makes collision with the second sphere of mass 2m with a velocity u1, then after collision, what about the velocities of the two spheres? Velocity of the first sphere after collision is equal to, here the type of collision is semi-elastic because they asked the coefficient of restitution. No, coefficient of restitution is even given. So 1/2. So after collision, after semi-elastic collision takes place between the two spheres, what is the velocity of the first body? What is the velocity of the second body? So velocity of the first body after semi-elastic collision takes place is, we can apply the law of conservation of linear momentum along the horizontal direction, because whenever the sphere comes to the lowest point, definitely along horizontal direction only collision takes place, and a line of impact also along the same direction. That's why we can apply the law of conservation of linear momentum along horizontal direction, and as the line of impact is also along horizontal direction, we can apply the Newton's law of restitution also along horizontal direction. Then you will get two equations in V1 and V2. You solve them, you will get V1 and V2. That is one method. Or by using these two equations only, we derive the formulas for velocity V1 and V2 after semi-elastic collision takes place. Okay, if you are having formula, if you are having idea about that formula, we can do directly. Otherwise, we have to apply the law of conservation of linear momentum and the law of conservation of Newton's law of restitution. Which method we have to do? Which method I will say? By direct formula or by law of conservation of linear momentum formula? Tell me. No, actually by applying conservation of linear momentum principle, that is the good method, because always we are unable to remember the formulas. Okay, by law of conservation of linear momentum principle, I will explain. So at the lowest point, along horizontal, according to law of conservation of linear momentum. Okay, you see, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 mass of this first sphere m into velocity u1. u1 means 2 into root gr. Velocity u1 means 2 into root gr. No, of course radius is given as a, not r. Radius is equal to a. That's why 2 into root ga you will get. 2 into root ga. you will get. Okay. So u1 means 2 into root ZA plus u2 is 0. u2 is 0. That's why it becomes 0 is equal to m1 means m into v1 plus m2 means 2m into v2. M we can cancel in all. Then 2 root ZA is equal to v1 plus 2 into v2. This is equation 1. Next, line of impact is also along the same horizontal direction only. That's why along line of impact or horizontal. According to Newton's law of restitution, E is equal to V2 minus V1 by U1 minus U2. Along line of impact only, these are the velocities. That's why we can do directly. E means 1 by 2. So V2 minus V1 is equal to U1 minus U2 whole by 2. U1 means 2 into root ZR minus U2, ZR means ZA by U2 0 by 2. 2 cancel. Therefore, V2 minus V1 is equal to 2 into root ZA we can write now. Sorry. V2 minus V1 is equal to root ZA. That's all. Root ZA. This is equation 2. From equation 1, V1 plus 2 V2 is equal to 2 into root ZA. Okay. Now from this, we have to obtain V1 and V2. When you know V1 and V2, we can find after collision how high the two spheres rises. We can calculate. You add these two, then 3V2 is equal to 3 into root ZA you will get. 3 cancel. So V2 is equal to root ZA. What about V1? V1 is equal to V2 minus root ZA. That is equal to V2 is equal to root ZA only. Root ZA minus root ZA cancel. So V1 is equal to 0 now. V1 is equal to 0. Okay, after first collision, you see, after first collision, all of you listen. After first collision, the first sphere comes to rest and second sphere fly off with a velocity root ZA. Okay, then with that velocity, the second sphere rises like this, and after velocity becomes 0, again they comes down. And after collision, first collision, the first sphere comes to rest. Velocity of the first sphere is 0. Velocity of the second sphere is root ZA means plus root ZA means the second sphere starts motion in this direction and it raises up to certain height and velocity becomes 0 and again they comes down. Again it makes second collision. After second collision, what about the heights reached? They asked. After second collision, what are the heights reached by the sphere? They asked. You see, find the heights to which the balls rises after second impact. After first collision, these are the velocities. After second collision, you see, here it is the lowest point of the circular tube. Here, with what velocity the second sphere rises, that is V2. Then again it makes collision with the, here again it comes down. The velocity acquired is equal to U2 is equal to root ZA only. U2 is equal to root ZA only. Because after first collision, with what velocity second sphere starts motion, that is root ZA. With that root ZA velocity, it rises and as the smooth surface only, no loss of energy. That's why with the same velocity, again it comes down. That's why with the same velocity it reaches the bottom with the same velocity. Initially, the first sphere is at rest. M1 is equal to M, M2 is equal to 2M. Initially, it is at rest. Now, this sphere makes collision with this first sphere in this direction. After collision, what about the velocity of this sphere? V1 is equal to how much? V1 is equal to how much? Again, you apply the law of conservation of linear momentum. V2 is equal to how much? We have to calculate. Along horizontal, according to law of conservation of linear momentum, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay. M1, of course, it becomes 0. Initial velocity of this first sphere is 0, no? Plus M2 means 2M into U2. U2 is along negative direction. That's why you write minus root ZA is equal to M1 means M into V1 plus M2 means 2M into V2. So therefore, m can be cancelled in all terms. Then v1 plus 2v2 is equal to minus 2 into root ZA. Okay, this is equation 1. Apply the coefficient of restitution. E is equal to v2 minus v1 by u1 minus u2. That is equal to E means 1 by 2. So what about v2? What about v2? V2 means we had to find v2 minus v1 we had to find by u1. u1 minus u2 means u1 is 0. u2 is ut is along negative direction. No? That's why you write minus u2 is equal to root ZA. Minus root ZA is equal to 1 by 2. Therefore, v2 minus v1 is equal to root ZA by 2. And v1 plus 2v2 is equal to minus 2 root ZA. Because this direction is considered as positive and this direction as negative. Okay, you solve these two. Of course, here you take velocity v1 and v2, you calculate. When you know velocities v1 and v2, definitely you will get one velocity positive, another velocity negative. v1 here in this case, v1 you will get positive, that is equal to root ZA. Sorry, you will get negative. v1 value you will get minus root ZA. v2 value you will get v2 is equal to root ZA by 2 you will get. Root ZA by 2 you will get. Of course, that means after collision, the first sphere move back with a velocity root ZA, second sphere move in this direction with a velocity root ZA by 2. Then what is the maximum height reached after second collision? So with this velocity, to reach the max, what is the maximum height reached means maximum height reached is equal to v square by 2z only. V square by 2z means root ZA whole square. Root ZA whole square by 2z means GA by 2z. GG cancel A by 2. That means first sphere rises up to a height A by 2. What about the second sphere? V2 square by 2z. V2 square means GA by 4 by 2z. That means by root GA by 2 whole square means GA by 4 into by 2z. That means GG cancel A by 8. I think first option you will get. After collision, after second collision, what are the heights reached by the first sphere? Second sphere means first sphere raises up to height A by 2, second sphere raises up to height A by 8. So heights raised are A by 2, A by 8. You will get these answers. Here you will get V1 is equal to minus root GA, V2 is equal to root GA by 2. You will get. You do that problem. You simplify them. You will get answer. So this is important one. Next, third problem you see. Yeah, with this velocity up to what height it raises means that is equal to root 2gh. H is equal to how much? V square by 2z. Because of gravity only, it rises up to certain height against the gravity. That's why here also we have to use the formula u square by 2z only. Vertically projected body, whatever the formula we use for maximum height reached, here also we have to use the same formula. Or you apply law of conservation of energy principle. At the lowest point, kinetic energy is half m1 into u1 square. When it rises up to a height h, no kinetic energy. That's why that is equal to mg into h. Then h is equal to how much? V square by 2z only you will get. V square by 2z only you will get. Okay. You see the next problem. Next, third problem. All of you see the third problem. All of you see the third problem. Third problem. Two spheres, each of mass m, each moving with a velocity u, moving in directions at 30 degree south of east and 30 degree north of east. So as north south directions are mentioned, geographic directions, north, south, east, and west. You mention here. Have you seen the problem? Okay, all of you see. All of you see the board now. All of you see the board now. Two spheres each of mass. This is one sphere, this is another sphere. Two spheres each of mass m, each moving with a velocity u, moving in a direction of 30 degrees south of east, something that is mentioned. That means geographic directions are mentioned. That's why first you draw the geographic directions: north, south, east, west. Okay, first particle moving 30 degrees south of east. South of east ante from east towards south at an angle 30 degree. The particle travel with a velocity u. With a velocity u, they travel. And the other particle travel north of east at an angle 30 degree. North of east means from east towards north at an angle 30 degree. Second particle of same mass m travel with the same velocity u. Like this. They collide each other. They collide each other and stick together. The velocity of the combination later becomes. Here these two particles travel like this and they collide each other and stick together after collision. Then what is the common velocity? They asked. Common velocity, say v. V bar is equal to question mark. We have to find. So here already I said, whenever the collision takes place along any direction, even force exerted by one sphere on this other sphere, that is the system of two bodies as a system. Then we can apply the law of conservation of linear momentum along any direction for the system, not for single body. So for the system, we apply law of conservation of linear momentum. As before collision, the two bodies travel in different directions. You write in vector form. Okay. So according to law of conservation of linear momentum, so m1 u1 bar plus m2 u2 bar is equal to m1 v1 bar plus m2 v2 bar. As masses are equal, we can cancel all masses. Remaining u1 bar, you write u1 bar in vector form. u1 is equal to u, you write in vector form. u2 is also equal to u, you write in vector form. u1 bar means, you see, their x component, y component. X component into negative, y component also negative. If it is 30 degree, this is 30. This is 30. Then x component is u cos 30 minus u cos 30 into y cap. Y component is minus u sin 30 j cap, because y component in this direction, x component in this direction. Plus for this particle u2 bar means x component negative, y component positive. No, if it is 30, this is 30. Then their x component is minus u cos 30 into I cap plus u sin 30 into j cap. This is equal to, after collision, as the two bodies stick together, v1 bar, v2 bar both must be same. v1 bar is equal to v2 bar, that is equal to v bar. So v bar plus v bar means we can write 2v bar. Okay, you see, minus u cos 30 I cap minus u cos 30 I cap means minus 2u cos 30 I cap minus u sin 30 j cap plus u sin 30 j cap. These two cancel. So after collision, the velocity of the combined system is this one. Here 2 cancel. Therefore, that implies v bar is equal to u minus u cos 30 into I cap. Minus u cos 30 I cap means what is the direction? After collision, the system of two particles or two spheres travel along negative x direction, means we have taken this as positive x axis, this as negative x axis. That's why minus u cos 30 I cap means after collision, the combined system travel towards west with a velocity u cos 30. So that is the answer. So what is the simplification here? Magnitude of this one is equal to u into cos 30 root 3 by 2. Root 3 by 2 towards negative x-axis means towards west, no? So west, u root 3 by 2 west, due west. West means towards west means that can be called as due west. So due west. This is the answer. It is also one of the important problems. Next one, fourth problem. That is also important one. Just 3 minutes is there, no? Baladitya, last 3 minutes. One problem we can do in last 3 minutes. Okay. Because that problem is important. They may ask in coming exam. This model they may ask definitely. That is a very, very important problem. Okay. You see the problem first. Fourth problem. All of you see the fourth problem. Okay. You see, a ball A collides elastically with another identical ball B. A ball A collides with another identical ball B with a velocity 10 meters per second at an angle of 30 degrees from the line joining their centers C1 and C2. Okay, here it is given as 30 degrees. Okay, velocity of the ball A after collision. Okay, all of you see the diagram. All of you see the diagram. You see, both are identical balls, so masses are same. Okay, initially the sphere A travel towards right with a velocity 10 meters per second. And the second sphere is at rest. So u2 is equal to 0 and u1 is equal to 10 meters per second. Here, the first sphere, a ball A collides elastically with another identical ball B with a velocity 10 meters per second at an angle of 30 degrees with the line joining centers of these two spheres. Centers of two spheres, line joining the centers of two spheres అంటే ఇదేగా. దీంతోటి 30-degree angle చేస్తూ, by making 30-degree angle with this line joining centers of the two spheres, the first sphere travel with a velocity 10 meters per second. That means this velocity direction is given with respect to the line joining these two centers. During collision, you see, at the point of impact or at the point of contact here, you draw a common tangent. Perpendicular to common tangent. When you draw perpendicular to common tangent passing through the point of contact, when you draw the line here, this is the line of impact and it is the common tangent. Along common tangent, as these two spheres are smooth spheres, here these two spheres are, friction is not given, means these two spheres are smooth spheres only. Okay, along common tangent there is no force acts on the particle, but along the line of impact the collision takes place is the elastic collision, that is given. Okay, you remember this point. First of all, before collision, what is the velocity component of the sphere A along this line of impact? Along line of impact in this direction, the velocity component is u1 cos 30, and along common tangent velocity is along common tangent u1 sin 30. Okay, so before collision, along common tangent the velocity component is u1 sin 30. Along line of impact, common velocity of the particle along common tangent, after before collision, velocity of this first sphere along common tangent is u1 sin 30. Along line of impact u1 cos 30. Okay, whenever collision takes place along common tangent as no force acts on them. So in case of first sphere, along common tangent as no friction is there, no change in velocity along this common tangent, that is u1 sin 30 only. That means along common tangent, velocity of the first particle is equal to u1 sine 30 only after collision. After collision, of course, it is x-axis, it is y-axis. Okay. Next, along line of impact, what is the velocity? Before collision, along line of impact, velocity of the first sphere is u1 cos 30. Along line of impact, collision takes place. After collision, you see the type of collision is elastic. Type of collision is elastic. That's why E is equal to 1. So along the line of impact, whenever collision takes place, as the masses are also same, because these two are the identical spheres, that's why mass are also same. Whenever two identical spheres having same mass, whenever collision takes place along line of impact, then the spheres exchange their velocities because of elastic collision. So after collision, as the before collision, velocity of the first sphere is along line of impact u1 cos 30, second sphere is 0. After collision, the first sphere acquires the velocity of the first before collision, means it comes to rest, and second sphere fly off with a velocity u1 cos 30. Just they exchanges their velocities. So velocity of the second sphere along line of impact is u1 cos 30, and velocity of the first sphere along this direction becomes v1. Suppose line of impact is say x-axis, this direction is say y-axis. So along line of impact, velocity of the first sphere becomes 0. Along this y-axis, after collision, velocity of the first particle along this direction is equal to u1 sine 30. That is only the net velocity of the first particle after collision. Whenever the velocity of the first particle after collision along this direction or along this direction is equal to u1 sine 30, then you write this in vector. You write this in, no, they asked the magnitude only. Along this direction, velocity becomes 0. Along this direction, velocity of the first particle becomes 0. Only along this direction, velocity of the particle is there for this first sphere. This is only the resultant velocity. Therefore, velocity of the first particle after collision is equal to u1 sine 30. u1 means, what is u1? 10. 10 into sine 30, 1 by 2. Therefore, v1 is equal to 5 meter per second. It is only the resultant velocity of the first sphere after collision. Yeah, 5 meter per second is the answer. No, not 0. Okay. Resultant velocity of the first sphere after collision is equal to 5 meter per second. This is the answer. Okay. Right. Right now. Have a nice day. I'm signing out. Advanced paper, definitely I will record and I will upload. Okay. Somebody asked me 4 problems they asked. 4 or 5 problems they asked. Okay. I will record those 4 or 5 problem solutions and I will upload in the YouTube. Yeah, I can stay for some more time. Tomorrow I can spend more time here. Remaining means yeah, tomorrow I will explain. Or if possible some problems I will making video and I will send to you. Okay. Right. I'm signing out. Have a nice day.